23 June, 1944, North Atlantic, a cargo submarine the size of a small merchant ship, cut a lonely line across dark seas. Commander Kameo Uno stood in I-52's conning tower and read the navigation fixes that would carry his boat toward occupied France. I-52 was on a Yanagi mission, one of the Imperial Japanese Navy's secret long-range exchanges with Germany, packed with strategic materials technicians and reports of payment gold and highly sensitive technical equipment bound. For Lorient, I-52 had left Kure in March, and after loading tin, rubber and specialist passengers in Singapore, made the long transit across the Indian Ocean into the Atlantic to meet a German U-boat for an escorted run north. The rendezvous itself was a dangerous choreography transfer, fuel German radio operators, and an Enigma cipher machine, so I-52 could attempt the last leg through the Bay of Biscay. Allied signals intelligence picked up and decoded the Japanese message, giving the meeting coordinates. From that moment, a hunter-killer group was steered to intercept. That hunter-killer force centered on the escort carrier USS Bogue, accompanied by 5 destroyer escorts, and Composite Squadron VC-69 of Grumman TBF Avenger torpedo bombers and FM-2 Wildcat fighters. Captain Aurelius B. Vosseler commanded the task group, which had been ordered to the Atlantic track where I-52 would appear. The Americans had been hunting submarines in these waters for months. Their carrier groups combined radar-equipped aircraft, airborne detection aids, and a growing arsenal of acoustic weapons into a coordinated system. Shortly after sunset on 23 June, Avengers from USS Bogue began night patrols in the area of the scheduled rendezvous, about 850 nautical miles west of the Cape Verde Islands. At roughly 2340 ship time, one Avenger, piloted by Lieutenant Commander Jesse D., Taylor picked up a small but definite return on his radar sweep. His radar was degraded, the right half of the sweep unserviceable, but the blip was enough. Taylor dropped flares to light the patch of ocean and fell into a pattern of attack and listen illumination, sonobuoy drops, and then a prosecution run. Those acoustic sensors sonobuoys were a recent innovation. Each buoy floated, dipped a hydrophone, and transmitted underwater sounds up to the aircraft. They were coded by color for pattern drops and allowed an Avenger crew to monitor multiple listening points in sequence. Taylor's radar contact vanished as the submarine dived. The Avenger dropped a purple sonobuoy, tuned into the underwater channel, and through hiss and prop wash heard rhythmical blade beats the signature of a propeller. Guided by those sounds, Taylor launched the Mark 24 acoustic homing weapon, a device the service labeled a mine in some documents to conceal its true purpose. The torpedo code named Fido homed on propeller noise and was the first operational Allied acoustic airborne weapon. For those aboard Bogue, the sequence read like the new doctrine in motion: radar pickup, flares, sonobuoy, drop acoustic homing weapon, and an operator listening to the buoys while air crews maintained station. The first attack produced a loud underwater explosion and sounds the airmen interpreted as hull failure. When Taylor relinquished his patrol, another Avenger flown by Lieutenant Junior Grade William D. Gordon arrived to continue the search with a civilian underwater sound expert aboard to help interpret faint signals. Over the next hour, the crews monitored sonobuoy returns and wire recordings. They heard distant propeller beats, a rolling explosion, then breaking and collapsing noises of a hull. In the morning, the destroyer escort USS Janssen recovered flotsam, rubber silk, and human remains near the contact. From the Japanese perspective, those hours were the last of a voyage already compromised by signals intelligence. I-52's rendezvous had been intercepted. Allied forces had been directed into position. For I-52's officers and crew, the Atlantic, once a corridor for stealthy transit, suddenly held aircraft on watch, listening microphones floating, like ghosts on the surface, and an acoustic weapon that would not need a visible line of sight to find them. The ocean's traditional privacy was pierced by a network of radar sonobuoy acoustics and airborne homing munitions, the very instruments the hunter-killer group had trained to weld together. The Americans later archived small technical records, radar bearings, sonobuoy serials, wire recordings in thin film canisters. But when stitched together, they describe a procedural triumph, a task group using signals intelligence radar, pickups, airborne sonobuoys, and the Mark 24 acoustic torpedo to locate and prosecute a submerged cargo submarine at night. Those thin technical threads are the story's backbone. They show how detection and remote acoustic sensing closed a gap in anti-submarine warfare, and why Japanese crews thereafter treated the open ocean as contested space. 24. June 1944. North Atlantic Night Watch shifted from chance to system. What the Americans had assembled around USS Bogue was not a single brilliant strike, but the deliberate marriage of several recently matured technologies: radar-equipped carrier aircraft, airdropped listening devices, sonobuoys, and the Mark 24 acoustic homing weapon together, driven by signals intelligence that had already handed the Allies 152's route. Those pieces, exercised in training and now in combat, turned an otherwise probabilistic hunt into a procedure. Sonobuoys were simple in concept and revolutionary in effect. A cylindrical float carrying a hydrophone and a short-range radio transmitter, each buoy dropped from an Avenger, could listen to underwater sound and beam that acoustic signature back to the aircraft. By pattern-dropping multiple buoys overlapping listening arcs, a crew could build an acoustic map of a submerged contact's propeller rhythm and bearing without needing to see the periscope or the wake. In the I-52 contact, the sonobuoys converted the ocean from a visually opaque volume into a monitored soundscape. The Mark 24 acoustic torpedo, nicknamed Fido in official parlance, closed the final tactical loop. Unlike conventional depth charges that sank on a predictable arc, Fido was effectively an airborne acoustic homing torpedo. It sought the strongest propeller noise and steered itself to intercept. Launched from aircraft circling a buoyed pattern, Fido reduced the window the submarine had to evade. In practice, the weapon favored the attacker's tempo. Once a propeller signature was locked, the submarine's options were limited to silent running procedures, which reduced speed and maneuverability and lengthened the time the hunter-killer group could hold contact. But hardware alone does not make doctrine. The Bogue group had been built around an operational lesson learned in months of Atlantic patrols: integrate radar, visual illumination, acoustic listening, and a weapon that could exploit what the sensors revealed. Radar crews in the Avenger could pick up a low profile at night. Pilots would drop flares to confirm a surface silhouette. If the contact dived, sonobuoys would be streamed into the area to listen. Operators would parse the buoys for pitch cadence and bearing, and then an Avenger would launch a Mark 24 to prosecute the signature. The procedure turned what had been a cat-and-mouse chase into an assembly line of detection classification attack. For submarine crews, the operational consequence was profound because it attacked their assumptions about when and where they were safe. Imperial Japanese Navy doctrine had long relied on surface transit at night to preserve battery life and make speed. Over long ocean legs, surface, running especially in bad weather or under the cover of darkness, had been the implicit defense aircraft. Detection was limited, and most anti-submarine weapons were shipborne. The sonobuoy-Fido combination erased that margin. An aircraft could drop listening buoys and, without waiting for a destroyer escort, prosecute a submerged contact with an autonomous homing weapon. The ocean no longer guaranteed concealment. Acoustic signatures could betray a submarine even when radar returns had vanished. These changes were procedural as much as technical. Training briefs for hunter-killer groups emphasized patterns and checklists: how many buoys to drop at given spacing, how to rotate crews to keep a continuous listening watch, and how to liaise with nearby escorting destroyers for follow-up surface search. In the Bogue action, those checklists ran under real pressure: radar intermittency, weather, and a large submarine whose size and cargo complicated assessment. But the system's redundancy mattered. Radar error could be papered over by flares. A single buoy's noisy return could be cross-checked by a second buoy, and a fired Fido that failed to immediately sink a target left the nearest escort to sweep for oil and debris. Technically marginal innovations, small transmitters, a hydrophone, a homing circuit, added up to operational parity. What the Americans gained at that moment was not invulnerability, but the ability to prosecute contacts at night and at range in a way that submarine captains did not fully anticipate. For I-52, The hunter-killer procedure meant any short surface run to gain speed or to effect rendezvous now carried a measurable risk. Aircraft over the horizon could turn the void into a listening grid and send a weapon to chase the sound. That procedural shift is why later Japanese accounts and Allied after-action reports read less like tales of singular heroism and more like documentation of a new mode of sea control, one that made the ocean easier to police and far harder to claim as sanctuary. 24-25, June 1944. North Atlantic dawn found the Bogue Group turning the night's thin technical traces into paperwork and decisions. In the Avenger cockpits and on the carrier's CIC, the night's audio returns, sonobuoy transmissions recorded on wire, were rewound and replayed until the cadence of the propeller became unmistakable. Lieutenant Junior Grade William D. Gordon sat hunched over a spool of thin wire, recording his headsets, muffling engine coughs, and listened for the sequence that would confirm what the flares and bearings suggested. A large, submerged hull had been hit and was failing. The recordings, the flare observations, and the later surface sweep by USS Janssen produced a convergent picture. An aircraft-launched acoustic weapon had homed on a propeller signature and produced catastrophic hull damage consistent with a sinking. The physical evidence was modest but telling. Sailors aboard the destroyer Escort recovered fragments that did not belong to Allied merchantmen, a length of Japanese-manufactured rubber pieces of lacquered wood and textiles, identified by intelligence officers as possible cargo, wrappings. Human remains were recovered in small non-sailor clusters. These were handled as both humanitarian and evidentiary, photographed, catalogued, and listed in the action report. On board, Bogue intelligence officers compared those finds to Japanese shipping manifests and to intercepted traffic indicating I-52's cargo and passenger list. The convergence of intercepted signals, radar arcs, sonobuoy bearings, FIDO employment, and recovered debris led the task group to the operational conclusion. They filed that evening, a large Japanese submarine that matched I-52's. The description had been prosecuted and lost in the contact area. The technical side of the assessment mattered because the action itself was procedural rather than theatrical. The wire recordings were analyzed for pitch cadence and the abrupt cessation of propeller noise, the acoustic signature of structural failure. Radio logs showed the sequence of events precisely. Radar pickup illumination buoy patterning, successive buoy returns, FIDO launch, and the final chaotic burst on the recording that observers described as a breaking noise. Intelligence reports that day appended Ultra and Allied HF intercepts, showing that the Japanese rendezvous signal had been compromised. Taken together, the material evidence and signals intelligence produced a strong operational judgment. The hunter-killer system had done what training intended it had taken, an intercepted plot, fixed a contact, and prosecuted it to result. From the Japanese side, the loss read differently, but with the same clarity of consequence. I-52 had been a high-value Yanagi boat, long-range, large displacement, and carrying not only raw materials, but technical experts and equipment in transit between Tokyo and Lorient. Japanese naval staff immediately registered the disappearance. An expected arrival failed to report, messages went unanswered, and plans for the scheduled German rendezvous collapsed into a missing asset. For submarine crews at sea, the loss signaled a practical lesson rather than a single tragedy. Routes once considered routine were now susceptible to coordinated airborne detection. Reports and later memoirs from IJN boat crews underline that fear not as rumour but as a change in operating calculus surface, runs at night once an accepted risk to conserve batteries and maintain speed, now carried the added danger of airborne listening devices and homing airborne weapons. Yet caution tempered triumph. American after-action files stressed uncertainties, radar intermittency, weather effects on buoy transmissions, and the difficulty of positively identifying a specific hull without survivors or a captured log. A prudent intelligence annex therefore listed the confidence level as operationally high but analytically cautious. Evidence favored an identification with I-52, but absolute certainty required more than acoustic signatures and flotsam. That caveat is the historian's anchor. The action's significance rests in practice and procedure rather than mythic finality. Operationally, however, the incident's immediate effect was concrete. Allied hunter-killer doctrine continued to emphasize integrated patterns. Radar pickups pushed aircraft into a buoyed listening web. Wire recordings routed to acoustic analysts, and FIDO became part of the standard airborne load for Avenger squadrons. For submarine commanders who read the intelligence summaries, the psychological effect was unmistakable. A floating array of listening devices and an air-launched homing torpedo meant that every transit could be surveilled from above and prosecuted without nearby surface escorts. Where once the ocean offered concealment by distance, now the acoustic dimension converted distance into vulnerability. In the days that followed, the Bogue Group's action was folded into doctrinal training and cautionary briefings. Tactical bulletins circulated among Atlantic hunter-killer groups, detailing buoy placement, FIDO employment patterns, and post-attack sweep procedures for escorts. In Japanese operational circles, loss reports and the failure of the Lorient rendezvous complicated logistics and eroded confidence in long-range surface transits. The I-52 contact therefore reads as both specific event and procedural exemplar, a night when recordings flotsam and a homing torpedo combined to demonstrate a new way of hunting submarines at sea. 24 June, 1944. Night above a black Atlantic that smelled of salt and engine oil, men traded sound and procedure for sight and surprise. Lieutenant Commander Jesse D. Taylor's Avenger rode the dark in slow arcs. The cockpit was a dim geometry of instruments, headset straps, and clipped orders. When Ed Whitlock called a faint echo on the radar, Taylor did not speak of glory. He spoke of task's flair, load buoy, pattern, attack, run. The crew moved with the economy of rehearsed motion because this was work they had practiced until it became muscle memory, a choreography of sensors, screens, and the cold press of decision. Below USS Bogue's Combat Information Center kept time in seconds and bearings. Officers logged contacts on grease pencils. Intelligence petty officers unspooled thin film recordings into portable players and listened through headsets. For them, a propeller's rhythm was not poetry, but data pitch cadence, a rising note that spooled into the harsh crack of an explosion. When a waveform snapped and silence followed the men, in the CIC did not cheer. They catalogued. They annotated times, transcribed pilot reports, and fed the traces into a slow institutional logic that turned sound into a tactical verdict. Lieutenant William D. Gordon came up to relieve Taylor with an acoustic analyst aboard Pricefish, whose civilian ear turned hiss into meaning. Gordon's crew recorded what later would be archived as thin film evidence voices, the faint propeller thrum, the approaching hiss of a homing weapon, and then a heavy structural crash. The spool preserved more than sound. It preserved the way ordinary people made sense of danger. Listening back, analysts replayed the same sequence until interpretation hardened into conclusion. For the men who handled the spool, the recording was a ledger entry, and a reminder that modern war increasingly left its proof in small technical traces. On the destroyer escorts, the work was different but equally exacting. USS Jansen's deck lights revealed crews hauling in flotsam by foam-streaked dawn, rubber fragments lacquered wood, lengths of fabric. Sailors catalogued debris, bagged samples, and photographed items, while petty officers compared the finds against manifests and intelligence summaries. Recovering a fragment of cargo carried a double weight, the immediate duty of recovery and the archival duty of proof. For the men on those decks, the action had no cinematic climax. It was a grim inventory, a methodical conversion of sea refuse into evidence. Far from the American CICs, the absence aboard the Japanese boat registered as administrative blanks that grew heavy. I-52's last radio check did not arrive. Scheduled signals went unanswered. The planned rendezvous collapsed into missing messages. The Japanese logs folded confidentiality into silence, expected arrivals that never came, crew lists that became lists of the unaccounted. For IJN crews at sea, the loss of I-52 read not as rumour but as practical instruction. The old calculus that made night surface runs routine was breaking down. Memoirs and later operational summaries capture this as a change in seamanship. An added fear that night might hide listening devices and weapons that found sound rather than sight. Human uncertainty threaded through both sides. Aircrews believed they had prosecuted a large submerged hull. Analysts later acknowledged the limits of acoustic identification. Acoustic ducts, surface layering, and distant propeller tones could complicate interpretation. Sounds carried in strange ways at night. Yet for the pilot who saw the blip, for the analyst who heard the hiss, for the sailor who held a fragment of silk on deck, the event had a psychological immediacy, a proof, however imperfect, that a new mode of hunting worked. For those on the submarine side, the psychological impact was the opposite routes, once judged tolerable, now felt surveilled. Small human details show the doctrinal shift. Pilots who had been trained to spot silhouettes now practiced dropping patterns of sonobuoys and listening through headsets for the cadence that meant life. Acoustic analysts who had once advised from shore rode in aircraft and spoke into combat radios, translating science into immediate instruction. Deck crews, trained for visual sweeps, learned to recognize an odd scrap of rubber or a wedge of lacquer as evidence. These mundane reassignments of skill mattered more than any single heroic act. They rewired how people performed their duties at sea. By dawn, the hunter-killer group had turned noise into paperwork, and men on both sides absorbed the same lesson in different keys. For the Americans, it was procedural validation. The system of radar sonobuoys and airborne homing weapons could be synchronized and produce results. For Japanese submarine crews, it became a cautionary tale that altered behavior at sea surface transits and scheduled rendezvous now carried an acute operational risk. The human record of that night is therefore less a tableau of triumph than a ledger of adaptation, people learning new routines, interpreting sparse evidence, and altering how they lived and fought on the ocean. 25 June 1944, North Atlantic, the I-52 contact, moved from a single night's work into instructional material. Operational staff rooms and squadron ready rooms rewrote emphases, sonobuoy pattern, geometry, FIDO employment arcs, and the choreography between airborne crews and surface escorts became checklist items rather than optional. Improvisations. The tactical truth made plain by that night was simple, and procedural detection could now follow a sound, and a homing weapon could be put on that sound from the air. The technical fact required doctrinal work, and doctrine once written changes behavior. Allied reports distilled the contact into discrete lessons. Avenger crews were instructed on optimal buoy spacing for differing sea states. Pilots practiced the timing between flare illumination and buoy streaming, so that the listening arc stabilized before a homing weapon was launched. CIC officers rehearsed protocols for transcribing wire returns and relaying acoustic bearings to on-scene commanders. Destroyer escorts incorporated these briefs into post-attack sweep templates, where a FIDO run failed to produce decisive sinking escorts, would hold a circular search pattern calibrated to the last buoy bearings and take immediate steps to collect flotsam and record oil slicks. These procedural refinements did not guarantee success, but they reduced uncertainty and sped decision cycles. The procedural shift had predictable tactical echoes for submarine captains. Where before a commander might surface at night for hours to preserve batteries and cover distance, new intelligence summaries and operational notes recommended severe curtailment of surface time in vulnerable zones and advised stricter emission control. Crews were encouraged to stagger rendezvous windows, shorten transfer operations, and avoid predictable routing through known interception corridors. The calculus of speed versus stealth tilted the time saved by surface running could no longer be counted as lost ground if it risked detection by airborne listening grids. Submarine captains therefore faced harder choices, longer submerged transits that preserved stealth at the cost of speed and habitability, or short surface bursts that exposed them to a coordinated airborne net. Logistics and planning also adapted. High-value Yanagi missions, boats of I-52's type, were re-evaluated for risk and, where possible, rescheduled or rerouted to minimize exposure in areas that intelligence marked as having strong hunter-killer coverage. Naval staffs tightened control over rendezvous notifications and introduced layered authentication procedures for meeting requests. The loss of a single vessel could no longer be absorbed as discrete attrition. The disappearance of a specialized exchange vessel carried both material and morale consequences, and staffs treated such losses as limits on the feasibility of long-range exchanges. Training and procurement followed doctrine. Production schedules for sonobuoys and the logistical chains that supplied them were scaled to ensure hunter-killer groups had sufficient stocks for sustained patrols. Aircrew syllabi added acoustic training. Intelligence sections integrated thin-film wire analysis into their standard duties, and carrier task group briefs included routine exercises in which aircraft dropped coded buoy patterns and analysts performed live wire replays. The effect was cumulative. The more crews practiced the sequence under realistic conditions, the more likely they were to execute it without drift when real contacts arrived. Procedure hardened into practice. On the psychological plane, the contact's lesson spread through both formal and informal channels. In Allied ready rooms, the I-52 action became a case study in the virtues of integration, signals intelligence that pointed planes to a position, pilots who could transition from radar to acoustic modes, and the weapon that closed the loop. In Japanese submarine pens, the same action filtered into cautionary conversations. Commanders warned junior officers that night. Surface, running, convoying with expected partners and routine radio checks could be compromised by airborne listening arrays. That change in tone, operational caution replacing confident routine, was as real a consequence as any technical metric. Operational art also adjusted at the margins. Hunter-killer groups learned to prioritize the preservation of acoustic evidence, careful logging of buoy serials, immediate cataloguing of recovered flotsam, and the rapid circulation of wire reels to shore analysis units. Conversely, submarine staffs refined contingency plans for compromised rendezvous, alternate points, time windows, and fallback fuel plans to reduce the systemic shock when a meeting failed. The old calculus of isolated risk gave way to a systems view in which detection, weapons, employment, recovery, and post-action analysis formed an interlocking chain. Critically, the I-52 contact did not create an invulnerable maritime police. Acoustic propagation, weather, and false contacts still complicated prosecutions. FIDO could fail, buoys could misread, and identification without survivors or logbooks remained inferential. But what the incident demonstrated and what doctrinal bulletins and training cycles embedded was a durable operational truth. The ocean's acoustic dimension could be exploited on scale, and exploiting it required synchrony between sensors, analysts, and weapons. That synchrony, when practiced, made the ocean a less forgiving environment for submarines that relied on the night's implicit privacy. Late June, 1944 North Atlantic, the night that the hunter-killer group closed around a single contact, did more than sink a vessel. It punctured an operational myth that had shaped submarine seamanship for decades. For submariners, the ocean had long been both shield and highway distance. Darkness and depth offered margins of safety that tactics and technologies rarely erased all at once. The I-52 contact did not instantly remove those margins, but it reframed them. Silence, previously an ally had become a betrayer. Acoustic signatures could be traced, recorded, and chased. That slow procedural erosion of confidence is the inflection this section follows, how routine assumptions turned into liabilities, and how operational doctrine bent in response. The collapse began in the way commanders recalculated risk. Surface running at night, a habit born of necessity and reinforced by experience, had been an accepted trade: conserve battery gain, speed, meet, rendezvous windows. After the contact, those trade-offs acquired new terms. Time on the surface now had a probabilistic cost, measured not merely in hours lost to dive and ride, but in the likelihood of entering a listening net. Commanders who once scheduled long surface transits began instructing staggered windows, shorter transfer periods, and dispersed rendezvous points. Where earlier doctrine privileged speed and habitability, revised calculations privileged stealth and unpredictability. The immediate effect was less dramatic than a fleet order. It was a cascade of small, cautious choices spread among skippers and patrol commands. Tactically, the inflection showed in adapted patrol patterns and new timings. Hunter-killer groups that had proved the procedure did not rest on a single model. They iterated. Aircraft crews refined buoy patterns for different sea states. Pilots and acoustic analysts tightened the choreography between radar sweep, flare run, and buoy streaming. Escort commanders practiced rapid post-attack sweeps to capitalize on leftover bearings. On the other side, submarine captains altered watch routines, reduced predictable radio traffic, and carved alternate fuel plans into orders of the day. Those changes were not uniform or universal, but they were widespread enough to alter the character of long-range exchanges and open ocean transits. The ocean began to demand more planning and less faith. Psychology proved as important as hardware. The sense that the sea could hide you eroded in quiet human ways. A sonar operator, who once nodded at routine surface, runs now checked maps for recent hunter-killer patrols. An officer on a submarine paused longer in the dark before ordering the boat to surface. A squadron ready room replayed wire spools until the waveform's abrupt stop felt like a warning more than a trophy. That change in comportment caution, ingrained into habit, illustrates the inflection's deeper power. Doctrine can order tactics. Habit makes doctrine durable. Once crews internalized the danger of airborne listening, their choices multiplied away from the old normal. At the operational level, the event tightened seals on logistics. High-value exchanges that required long, predictable legs were re-examined. Staff planners bolted layers of authentication onto rendezvous protocols, and in some cases postponed or rerouted transfers. The loss of a single specialized boat thus had ripple effects. It was not merely a ship lost, but a logistical node removed from an already constrained network. That systemic sensitivity exposed a second, subtler collapse. Not only had the ocean become surveilled, but long-range planning could no longer treat a given transit as reliably repeatable without additional security measures. Yet the collapse was neither absolute nor instantaneous. Acoustic propagation remained subject to weather thermal layers and chance. False contacts persisted. Fido did not always find a valid target. Buoys could be damaged in deployment. The inflection was therefore pragmatic. It did not promise omniscience to hunter-killer groups, but it demanded respect for a new dimension of risk. In that practical recognition lay the operational learning maritime advantage, to no longer rested on a single technological edge, but on synchrony between sensors, analysts, and weapons, and on the organizational ability to practice that synchrony until it became dependable under stress. Finally, the inflection reshaped narratives. Where submarine warfare had once been told as tales of stealthy transit and sudden surface triumphs, post-contact accounts emphasized systems. Reports, debriefs, and later doctrinal write-ups frame anti-submarine success as the product of combined procedures, signals intelligence that set the stage, radar that found the hint, buoys that listened, analysts who read the patterns, and weapons that closed the loop. The romance of clandestine sea travel gave way to the sober admiration of procedure. That reorientation, less lyrical, more procedural, marks the collapse of the old myth and the birth of a new operational reality in which the ocean's silence could no longer be trusted without verification. June-July, 1944 North Atlantic, into post-war doctrine. The night the hunter-killer group prosecuted a submerged contact did not by itself rewrite naval history, but it left durable traces across tactics, procurement, intelligence, tradecraft, and the memories of sailors on both sides. In the immediate weeks after the action, the Allies codified lessons, sonobuoy, patterns, Fido employment arcs, post-attack sweep templates, and the imperative to pair signals intelligence with airborne search. Task group after-action briefs circulated these practices from carrier decks to squadron ready rooms. They were folded into syllabi for new pilots and into checklists for CIC officers. The procedural seed planted on that night matured into doctrinal habit. Operationally, the most visible legacy was the normalization of airborne acoustics as an ASW pillar. Sonobuoys moved from experimental adjuncts to standard equipment carried by carrier-based and land-based patrol aircraft. The Mark 24 acoustic homing torpedo, Fido, proved the concept that an airborne weapon could home on sound and changed the calculus of engagement detection could be rapidly followed by prosecution without waiting for surface escorts. Hunter-killer groups, once improvisatory, became more methodical. They trained to weld radar flares, buoys, and homing torpedoes into a single loop that could be executed by a small, well-drilled team. That procedural loop narrowed reaction times and expanded the reach of ASW patrols. Logistically and industrially, the event contributed to shifting priorities. Production and supply chains for sonobuoys and airborne acoustic munitions were expanded. Maintenance and replacement schedules were written into carrier manifests, and procurement planners valued aircraft capable of both radar and acoustic roles. Training budgets allocated more hours to acoustic recognition and wire reel analysis. The tactical modesty of devices, a hydrophone, a small radio transmitter, a homing gyroscope, belied their strategic value once they were produced and distributed at scale. The I-52 contact is therefore best read not as a single technological theft of advantage, but as an accelerant. It pushed existing tools from prototype to program. For submarine operations, the legacy was behavioral and strategic. Japanese submarine doctrine had already been strained by attrition and by the growing dominance of Allied air power. The demonstrated ability to locate and prosecute submerged contacts at night added another constraint. Commanders adjusted more conservative surface, running tighter emission control dispersed and staggered rendezvous plans and an increased appetite for submerged endurance at the expense of speed. The disappearance of a high-value Yanagi boat had logistical consequences beyond the loss of material. It undermined confidence in a class of long-range exchanges that Tokyo had relied on for critical technical transfers. The diplomatic and industrial implications delayed, deliveries lost expertise, and disrupted German-Japanese cooperation were tangible and immediate. Historiographically, the incident occupies two overlapping verdicts that scholars balance today. First, there is consensus that the action exemplified how integration of sensors, analysts, and weapons produced operational effects that changed intra-theater risk calculations. Contemporary doctrine and post-war ASW developments reflect that learning. Second, there remains contested analysis about the degree of finality the action achieved in identification and attribution. Allied records emphasized convergent evidence, radar arcs, sonobuoy traces, recovered debris and decrypts, but analysts have with decades of acoustic science cautioned that acoustic propagation and environmental ducts complicate retrospective certainty. The prudent historical reading privileges the procedural and doctrinal import, while acknowledging limits on absolute forensic closure. The episode's technical lessons also threaded into Cold War ASW. The basic insight exploit the ocean's acoustic dimension by dispersing listening nodes and pairing them with homing weapons underpinned. NATO investment in sonobuoy fleets improved acoustic signal processing and coordinated air-sea hunting methods in the 1,950 seconds and 1,960 seconds. The maritime surveillance architectures of the Cold War were not simple extensions of wartime practice, but they were shaped by the same logic. Sensors multiplied reach, analysts converted noise into vectors and weapons, executed on that vector. In that institutional lineage, the Bogue Group's night patrol is an antecedent, a procedural ancestor of systematic peacetime maritime surveillance. Culturally, the contact entered service narratives differently. For Allied aircrews and escort sailors, it is a case study in integration, less a tale of individual valor than an example of teamwork, patience, and technical literacy. For Japanese submarine veterans, the loss contributed to a shifting seamanship, ethic caution, supplanted routine, and the sea's presumed sanctuary was questioned. Memoirs, training notes, and naval staff directives from both sides register the same effect, a change in behavior anchored in small technical facts that had outsized operational meaning. Finally, the incident offers a methodological lesson for historians and practitioners alike. Military innovation is often incremental and distributed. It advances when marginal technical improvements are disciplined into repeatable procedures and then institutionalized through training, procurement, and doctrine. The I-52 contact illustrates that pattern-modest devices became decisive when they were woven into a reliable chain of detection, interpretation, and action. That is the episode's enduring legacy, an operational truth about how war adapts when men and machines learn to work together, turning the sea's silence from refuge into information.